Right, quick 5-minute overview of capacitors. Basically, capacitors are used to store charge. The construction is fairly simple: two plates separated by a material or air called the dielectric. In a circuit, when the switch is closed, charge will flow around the circuit and accumulate on the capacitor plates. One plate becomes positive and one plate becomes negative, and charge is stored. The charge on each plate is equal, but it's opposite. When the capacitor is fully charged, the voltage across the capacitor, across there, is equal to the voltage across the supply. An electric field exists between the plates of the capacitor, and the flow of charge will stop. When charging, well, immediately the switch is closed, charge in the capacitor would be 0, and the voltage of the supply here will equal the voltage across the resistor plus the voltage on the capacitor. As charge is rushed to the capacitor, the current is high. So as current initially rushes down here, there's a large flow of current, and charge is accumulated rapidly on the plates. As the charge on the plates rises, the voltage across the plates rises, across here, and the voltage correspondingly across there drops. Remembering the voltage of the supply up here is equal to the sum of the voltage across the resistor plus the voltage across the capacitor. Okay. Charge builds up on the capacitor exponentially. So over a period of time, it becomes asymptotic with a maximum value there of the supply voltage of the battery. Similarly, the amount of current flowing decreases exponentially. The time constant is equal to the value of the resistor times capacitor. And it has a symbol torr. One time constant, is the time taken for it to be 63% charged. 2, 3, 4, 5. After 5 constants, we effectively say that the capacitor is 99% charged. And very importantly, don't forget, a fully charged capacitor blocks DC current. Once it's fully charged, no more current can flow.